The wonders of our universe are never-ending. Every year, scientists and researchers make unexpected discoveries, helping us to slowly understand our place in the universe. So today, here at Unexplained Mysteries, we'll be taking a look at 3 interesting space discoveries. A fast radio burst was detected from our galaxy for the first time. Fast radio bursts, also known as FRBs, are rare flashes of bright light that appear only for a few milliseconds and have puzzled scientists for years. They are intense pulses of radio waves that release tons of energy. They release more power in just a few milliseconds than the sun does in an entire century. The first recorded instance of an FRB sighting was in 2007, but it was not until 2018 that a telescope was set up to track them precisely. These odd flashes of light register on the radio band of the electromagnetic spectrum for a fraction of a second. There is no known origin or explanation for where or when they appear, which means you have to be lucky and point your radio dish in hopefully the right direction to capture one. The leading theories of FRBs are that they originate from magnetars, a type of neutron star that died in supernova explosions. Magnetars are considered the most powerful magnets in our universe and have been known to erupt into giant flares and produce X-rays and gamma rays, implying they could also create FRBs. Throughout the years, scientists have been able to identify nearly 150 various flashes within our universe. Within the past 2 years, though, that number has almost quadrupled with the success of a large stationary radio telescope set up in British Columbia. The CHIME telescope, short for the Canadian Hydrogen Intensity Mapping Experiment, was first set up in 2018 to observe and catalogue potential FRBs. In just its first year, CHIME detected 535 new fast radio bursts and provided detailed insight into their properties, which researchers are using to pinpoint their origins. In late April 2020, the CHIME telescope and the Survey for Transient Astronomical Radio Emission 2, or STARE-2, antennas in California and Utah detected a new fast radio burst. This burst, named FRB 200428, is the brightest burst that researchers have ever seen in our own galaxy. They explained that it was about 3,000 times more brilliant than any other signal they have catalogued, and that if you possessed the recording of raw data from your phone's 4G LTE receiver, you could potentially have seen the radio signal on your phone. FRB 200428 was also the first burst to be traced to a magnetar, thus confirming the researchers' leading theory. It also was accompanied by X-rays a day later, another first. Multiple space telescopes around the world detected these X-ray bursts, all originating from the exact location and at the same time. This fast radio burst occurred in Vulpecula, a constellation set in our galaxy's centre, about 30,000 light-years from Earth. Although this observation strengthens the magnetar theory with the accompaniment of X-ray emissions, scientists are still unaware of how exactly these bursts form or how they behave. Researchers are now intrigued with the possibility of directional bursts pointed away from the Earth, which would be undetectable to us and our telescopes. They will continue to monitor the sky and hopefully find further information to solve this mystery. Elon Musk will fly to space with Virgin Galactic. On July 11, 2021, the first fully crewed spaceflight of Virgin Galactic's VSS Unity took off with Richard Branson, the billionaire and founder of the Virgin Group, on board. The group aims to begin its commercial operations early next year, as the test flights have all been successful so far. Branson confirmed to the Sunday Times recently that Elon Musk has also reserved a seat on a future suborbital spaceflight by putting down a $10,000 deposit. There is no confirmation on which flight he will be a part of or when it will occur. Tickets for Unity flights have been priced around $250,000. So far, many celebrities have purchased tickets aboard future Virgin Galactic flights, like Tom Hanks and Lady Gaga. Richard Branson and Elon Musk are friends and have supported each other's space endeavors for years now. Musk was in attendance in New Mexico to witness Branson's flight launch at Spaceport America, the commercial hub for Virgin Galactic. They even took a picture together beforehand, which Branson uploaded to his Twitter account. Musk is also building spaceships with his company SpaceX, which is planning to operate commercially, taking people to the Moon, Mars, and hopefully beyond. Although SpaceX has been constructing and testing its rockets for many years now, they are still behind in this business race, which is perhaps why Musk booked a ticket on a competitor's ship. He might be too eager to exit the stratosphere to wait for his own shuttle. Virgin Galactic is the only space tourism company with permission from the Federal Aviation Administration to bring their customers to space. Both SpaceX and Blue Origin, Jeff Bezos' company, are yet to qualify for clearance. The main difference between these three space tourism companies is the type of launch and height they all achieve. Virgin Galactic deploys and descends its ships horizontally like a plane on a runway, while the others take off vertically. Branson's Spaceship 2 is actually led to the upper atmosphere by a mothership and then deployed to rocket itself past the stratosphere. Although it travels into suborbital space, it still fails to pass the Kármán line 62 miles up, which most scientists and authorities regard as the official beginning of space. Both Musk and Bezos' space planes are designed to pass this boundary, affecting potential tourism for Branson since most people will want to fly in actual space. Despite the enthusiasm and excitement, Virgin Galactic has yet to release a schedule or itinerary for their next space tourism flight. It might even take another year or so until Musk can experience a suborbital flight aboard Branson's ship, so he will have to be a little more patient. Who knows, by the time the next flight occurs, his own rockets might be ready and cleared for space tourism as well. Dozens of starless rogue alien planets possibly spotted. Throughout the years, scientists have discovered more and more exciting details about space and how our universe operates, often contradicting previously held theories and facts. As it turns out, planets do not need to be tethered to and orbit a star. Astronomers have discovered various free-floating planets which travel through space on their own, untethered. Researchers have been collecting data from NASA's Kepler Space Telescope for years, poring over the data to identify possible rogue exoplanets and find evidence of other Earth-like planets. This existence of untethered planets was found in Kepler's database from a 2-month observation in 2016 during its K2 mission phase. During this time, Kepler had observed millions of stars in the center of our galaxy every half hour. The researchers were eager to study the data and hopefully find evidence of gravitational microlensing events. These occur when a massive object's gravity bends the light of a distant star, acting like a magnifying lens through which we can observe things usually too far away to see. For 2 months, Kepler spotted 27 short-duration signals, some of which lasted upwards of 10 days long. 4 of the shortest signals were consistent with planets that were about the same mass as our Earth. With this data, scientists were able to reason the existence of free-floating exoplanets. If there were a host star and a planet in orbit, they would have found a more extended signal. The leading theory is that these planets were initially formed and orbited around a host star but were pulled away by a stronger gravitational force. It was not easy for scientists to uncover this evidence, as they had to navigate through vast amounts of data and crowds of stars. Kepler was designed to find planets using the transit method, where stars dim when a planet crosses in front of it, not this microlensing method of observing dense star fields. The data the telescope collected was blurry, hectic, and crowded, making it extremely difficult for the researchers to pinpoint the minimal changes in brightness that last only briefly. The telescope itself was a decade old and did not provide the same quality picture as newer telescopes. One researcher compared the work to trying to find a firefly in the middle of a busy highway only using your cell phone camera. It should be noted that while these findings are intriguing and exciting, they do not prove the existence of the free-floating planets. researchers had to develop new techniques and strategies to analyze Kepler's data and find the possibility of rogue planets, but their work remains unfinished. Since the Kepler telescope was decommissioned in 2018, researchers are turning their sights to others that have the capability of spotting microlensing events. NASA's Nancy Grace Roman Space Telescope and the European Space Agency's Euclid mission both have the potential to provide the data that confirms the existence of these rogue planets. It will take further observations and studies until they can conclude their theories, possibly extending for several more years. But what do you make of these space findings? Be sure to let us know your thoughts in the comment section below and help us by growing this community while working to solve these unexplained mysteries. Thank you for watching, and don't forget to subscribe for more videos.